Okay, let's work a couple practice problems here on solving for energy. This first one here, I have a book on the shelf. This one I'm going to be solving for gravitational potential energy. So I need to write out mass, gravity, and the height. Mass is 4. Gravity on Earth will always be 9.8 meters per second squared, and the height in this case is 6.5 meters. My equation is GPE equals mass times gravity times height. Plugging in those numbers that I just wrote is going to give me 254.8 joules. So it's a measure of energy. Next one, I'm looking for kinetic energy. In this case, I only need two variables, the mass and the velocity. So the mass in this case is 2.6 kilograms. The velocity is 9 meters per second squared. My equation is kinetic energy is 1/2 mass, and make sure the only part you square is the velocity. So I'm going to put in my numbers, 0.5 times 2.6 times 9 times 9. Easiest way is probably just to put the two numbers right next to it rather than trying to square it. So this one is going to work out to be 105.3 joules, same as my potential energy. This last one here, I'm going to need to do a little bit of algebra on. Now, instead of writing out the mass, the gravity, and the height, I already have the gravitational potential energy. I need to solve for the mass. So it's a little bit of algebra here. So 94 joules, 9.8 meters per second squared, again, as long as I'm on Earth. And then the height is 2.3 meters. In this case here, here's my original equation. GPE equals mass times gravity times height. Now I really want to isolate the mass. So what I'm going to do is essentially a little bit of algebra, divide both sides by gravity times height, which is going to cancel that out. So my equation is the mass is gravitational potential energy divided by the gravity times the height. From here on out, it's just a simple matter of plugging in my numbers, 94 joules divided by 9.8 times 2.3. Set that up a little bit more. I'm going to need to figure out what 9.8 times 2.3 actually is. That's going to give me 22.54. 94 divided by that number is going to give me 4.17 kilograms. That is the mass of this book. A little bit of algebra got me there. Next up here, I'm going to be looking for what is the potential energy of an 85 kilogram diver standing on the diving board 4 meters above the pool. So mass is 85, height is 4 meters. As long as we're on Earth, it's 9.8 meters per second squared. So GPE is mass times gravity times height. Plugging in my numbers there is going to give me 3,332 joules. Next one here, I'm looking for another kinetic energy. All I need is mass and velocity. I should have put meters per second there. 1/2 mass times the velocity squared is going to give me 0.5 times 45 times 6 times 6. Plugging all that in is going to give me 810 joules of kinetic energy. Couple others here. This one, pitcher throwing a baseball at velocity. What is the kinetic energy? There's my mass and velocity. 1/2 mass times velocity squared is going to give me 0.5 times 0.254 times 25 times 25. That's probably just the easiest way to square something so you don't make any screw-ups there. That is going to give me a total of 79.375 joules. This last one here, I'm looking for another gravitational potential energy. My mass is going to be 45 kilograms. Height is that. Gravity will remain the same as long as we're on Earth. Plugging all that in is going to give me 1,984.5 joules of gravitational potential energy, which is at the top of the stairs. All right, now this one we're going to be comparing Mr. Carlson versus Miss Erickson. I would be running at 70 kilograms and 3.3 meters per second. Oh, I'm Mr. Carlson, by the way. Miss Erickson will be 55 kilograms and 8.2 meters per second. So I'm going to be calculating both of our kinetic energy and seeing who's higher. Mine works out to be 381.15 joules. Hers, however, she has less mass than I do, but is running significantly faster. So let's see how that works out. Same equation as before. This one is going to work out to be 1,849.1 joules. So to answer the question, who has more kinetic energy? It is Miss Erickson by a long shot. That velocity squaring makes a huge difference. Last one here, 3.8 kilogram ball thrown straight up in the air with initial velocity of 4 meters per second. What's the kinetic energy when it's first thrown? Well, I can do that one right here, as you've seen before already half a dozen times. That one's going to give me 30.4 joules. So that's what the kinetic energy is when it's first thrown. I'm not going to tell you what the kinetic energy is at the top of the ball's path. That's what you need to figure out.